back to Rockpile Tutors. Today we're doing a quick video with a couple of simplifying radicals problems sent in by a student. And here we go. First problem is using radicals essentially as regular numbers and then just dealing with the fact that they're radicals later. So this is set up and it is set up for distribution. So the first thing we're going to do is distribute. You also may know this as foiling, because we're going to essentially make sure that everything multiplies by everything else. So first outer, inner, last. So we are going to do the first terms, which gives me 2 times the square root of 3 times the square root of 3. We'll deal with that in a bit. Outer minus 5 times the square root of 3 times the square root of 6 plus 2 times the square root of 3 times the square root of 6 and minus 5 times the square root of 6 times the square root of 6. So there's a couple of things that we're doing here. One is we know that when we multiply the square root of anything times itself, we're going to get that original number. So this becomes 6 and this becomes 3. Sorry, 3 and 6. Now next, if we multiply square roots that don't have the same base, then we multiply the two numbers together, and this becomes the square root of 18, and this becomes the square root of 18. So now that we've distributed, we combine like terms. And I'm going to write 2 times 3 minus, so minus 5 plus 2 is going to be minus 3 times the square root of 18 minus 5 times 6. I'm going to combine those, and then 6 minus 30, I'm going to do that in one sec. So that becomes that, and now what I want to do is we're going to simplify the radical. And typically we do that with a factor tree. And so here I've got 9 times 2, 2 is prime, 3 times 3, both prime. And I'll come over here and show you that 3 times the square root of 18 is equal to 3 times the square root of 2 times 3 times 3. When we have 2 under a square root, we cross them out and bring one outside. And so this becomes 3 times 3 times the square root of 2, or 9 times the square root of 2. And then the final step is to bring everything together. I have 6 minus 9 times the square root of 2 minus 30. I can't do anything with the square root of 2 because that's not a like term, but I can combine the 6 and the negative 30, and I get minus 24 minus 9 times the square root of 2. And that's how we do it. Let's take a look at the next problem now. What we're going to do involves cubed roots and dividing roots. So what I'm going to do here is I'm going to first put the entire problem under a single root. So I'm going to do the cube root of 7 over 56, and then I can cancel here and divide both top and bottom by 7, and so now I get the cube root of 1 over 8. All right, so here what we're going to do is we're going to jump into roots being fractional exponents, and I'm going to rewrite this first as 1 over 8 to the 1/3 power, right? That is the definition of a cube root. Cube root is a fractional exponent. And now I'm going to look at 1 over as a negative exponent. So this is now 8 to the negative 1/3, right? Because by taking a negative, that puts 1 over, and then I would take the 1/3 root, so that would be 1 over the cube root of 8. Now I'm going to do a factor tree of 8, 4 and 2, 4 is 2 and 2. So 8 is 2 to the third. Now I'm going to rewrite this over here as the cube. No, I'm not. I'm going to rewrite this as 2 to the third to the negative 1/3. And when I am taking exponents to exponents, I multiply them. So that is going to equal 2 to the negative 1, or 1/2. So in this one, what we do is we simplify what's inside the radical by taking it as 7 over 56. I see that as the cube root of 1 over 8. And then I switch into exponent form and I change 1 over 8 to the 1/3. I recognize 1 over 8 is 8 to the negative exponent. And then I change 8 into 2 cubed, and then I can multiply exponents and get 1/2. All right, I hope that you enjoyed this. And if you're interested, come find me at rockpiletutors.com. Thanks a lot.